Good afternoon to all. I am Dr. Parvathi Devi, working as an Associate Professor in Civil Engineering Department in Marri Laxman Institute of Technology and Management. So today I am discussing about bearing systems in surveying. Let's move on to the topic. So before knowing the bearing systems in surveying, we need to know some terminology related to this bearing system. So first one is meridian. A reference line for measuring direction of a given survey line is known as a meridian. And bearing. Bearings are the angles measured to determine the direction of survey line related to a reference meridian. And importance of bearing systems in surveying. So in order to measure accurate determination of direction of a line, and also it is used in navigation, surveying and mapping. There are mainly two different types of bearing systems used in surveying. First one is whole circle bearing system or azimuthal bearing system, and second one is reduced bearing system or quadrantal bearing system. Let's move on to the topic whole circle bearing system. In whole circle bearing system, all bearings measured in clockwise from the north direction of the reference meridian. This system is also known as azimuthal system. The horizontal angle made by a line with the magnetic north in clockwise direction is the whole circle bearing of the line. And in whole circle bearing system, magnetic north will be 0 degrees, magnetic east will be 90 degrees, and magnetic south will be 180 degrees, and magnetic west will be 270 degrees. And whole circle bearing varies from 0 to 360 degrees. And this bearing system is fundamentally used in prismatic compass. So let's understand the definition of this whole circle bearing system. So the horizontal angle made by a line with the magnetic north. So this is magnetic north, and if this one is our survey line, then the angle measured from the north in clockwise direction towards survey line. So this angle is known as whole circle bearing of this OA survey line. Let's see in detail. So if our survey line falls in first quadrant, so it varies from the angle, or whole circle bearing varies from 0 to 90 degrees. So this is magnetic north, and this is east, south, west. So this is 0 degrees and 90 degrees, and next 180 degrees, 270 degrees. Okay. So if our survey line lies in first quadrant, so that is north to east, so that is from 0 degrees to 90 degrees. So we will denote this one as theta, and we will measure the angle from north towards our survey line in clockwise direction, and this theta in this first quadrant varies from 0 to 90 degrees. Next, when our survey line lies in second quadrant, then whole circle bearing value of this line varies from 90 degrees to 180 degrees. So again we will measure from north in clockwise direction towards our survey line. So this is theta, and if our survey line is in second quadrant, we will measure from north towards survey line in clockwise direction, and the value ranges between 90 to 180 degrees. That is, which means the survey line may be here or here or here, and the range is between 90 to 180 degrees. And next, if our survey line is in third quadrant, the theta value ranges between 180 to 270 degrees. OC. And we'll measure the angle. We'll measure the whole circle bearing from north towards our survey line in clockwise direction. So this value ranges between 180 degrees to 270 degrees when our survey line lies in third quadrant. Then coming to last one, when our survey line is in fourth quadrant, so it ranges between 270 to 360 degrees. Again we'll measure from north towards our survey line in clockwise direction only. So this theta ranges between 270 to 360 degrees, which means our survey line may be anywhere in between this quadrant. Okay, I hope this is clear. You should remember that whenever we are considering whole circle bearing, we are measuring the angle or the bearing from north towards our survey line in clockwise direction only. Then we'll move on to second topic, reduced bearing system. In reduced bearing system, bearings are measured from the nearest north or south direction towards east or west. This system is always known as, this system also known as quadrantal bearing system. The horizontal angle made by a line with the magnetic north or south, whichever closer from the line, in the eastward or westward direction is the reduced bearing of the line. In quadrantal bearing system or reduced bearing system, both north and south are considered as reference meridians, and depending upon the position of a survey line, the direction of the reference meridian to the line can be either clockwise or anti-clockwise. And in the expression of the reduced bearing values of a line, quadrant has to be mentioned in which the line is. This bearing system is fundamentally used in a surveyor compass. Let's understand the definition first. Now, in reduced bearing system, we have two reference meridians. First one is north and second one is south, and the angles measured eastwards or westwards, angles or bearings. And what it says? So, whenever survey line is near to north, we will measure from the north, and if it is towards near to south, we will measure from south, either clockwise or anti-clockwise. We will see in detail in the next slide. If survey line falls in first quadrant, we have two reference axes and east, west. This is O. Let's take this one as O, and if our survey line is in this first quadrant, OA, I'll call our survey line as OA, and north to east, it lies in between, our survey line is in first quadrant. So, we will measure from north towards OA in clockwise direction, because it is near to north we are taking, and it is near in clockwise direction. So, we are measuring like this. in clockwise direction. From north we are measuring in clockwise direction and say this one as theta, and we will denote reduced bearing of this line as north theta east. First we will write the first reference axis, that is north, and which side? Eastwards. So we will denote here east and theta. So north theta east. And in next case, if our survey line is in second quadrant, now our survey line is near to south, so I will measure from south towards our survey line, that is towards east in anti-clockwise direction. I will call this one as theta 1, say theta. And what are the directions? First we are taking south as the reference and we are measuring towards east, so I will write southeast, and the angle is theta. And if our survey line is in third quadrant, again the nearest reference is south only, and we will measure the angle in clockwise direction. South is if our survey line is in third quadrant, south is the nearest reference axis and we are measuring the angle in clockwise direction. So if we say this one as theta and the reference axis is south and we are measuring in westward direction, so that is W and angle is theta. Okay, if it is in third quadrant. Next, if our survey line lies in fourth quadrant, I will name our survey line is OD, and which is nearest? The nearest reference axis is north and we are measuring it from north in anti-clockwise direction. If we say this angle as theta, then our reference axis is north and the angle is measured in westward direction. So west, the angle is theta. So north theta, west. So I hope this one is clear. Then move on to the difference between these two bearing systems. We know how we are going to measure whole circle bearing and reduced bearing. So and where we are applying these systems also we know. So first one, when we are using whole circle bearing, whole circle bearing system is used in prismatic compass and reduced bearing system is used in surveyor compass. First we will see the major differences between these two bearing systems. First difference is the horizontal angle made by a line with the magnetic north in the clockwise direction is the whole circle bearing of the line, and in reduced bearing is the horizontal angle made by a line with the magnetic north or south, whichever is closer from the line, in the eastward or westward direction is the quadrantal bearing or reduced bearing of the line. So that is whole circle bearing system. We have north and we are going to measure in clockwise direction only, and in reduced bearing system, the reduced bearing is measured from north or south, in eastwards or westwards, that is either clockwise or anti-clockwise, whichever is nearer to our survey line. Then second difference is the magnetic north line is considered as a reference line in whole circle bearing system, and in reduced bearing system both north and south lines are considered as reference lines in quadrantal or reduced bearing system. So as I said, north, we are going to take north as the whole circle bearing system reference, and north and south are the references in reduced bearing system. And the next difference is the clockwise angle from the reference line is only taken in whole circle bearing system, and both clockwise and anti-clockwise angles from the reference line is taken in reduced bearing or quadrantal bearing system. The value of the whole circle bearing varies from 0 to 360 degrees, and the value of the reduced bearing varies from 0 to 90 degrees only. And for example, the whole circle bearing may be 20 degrees, 120 degrees, 200 degrees, 330 degrees, etc. And reduced bearing system examples are north 20 degrees east, south 60 degrees east, south 20 degrees west, or north 30 degrees west, etc. And this, as I said, this bearing system, whole circle bearing system is used in prismatic compass, and reduced bearing system is used in surveyor compass. Now we got the clear idea about whole circle bearing system and reduced bearing system. Now, if I want to convert whole circle bearing to reduced bearing or reduced bearing to whole circle bearing, we have some procedures. So we will see one by one. Now we will see the whole circle conversion of whole circle bearing to reduced bearing. When the angle is in when our survey line is in first quadrant, whole circle bearing value is 0 to 90 degrees. That is north to east, that is 0 to 90 degrees. So, and conversion for this this whole circle bearing to reduced bearing is theta, whole circle bearing to reduced bearing conversion. When the angle is in first quadrant, the value of the whole circle bearing is 0 to 90 degrees, and if the angle, the survey line is in second quadrant, the value is 90 degrees to 180 degrees, and in third, if it is in third quadrant, the alpha value is 180 degrees to 270 degrees, and if it is in fourth quadrant, 270 to 360 degrees. What are these? These are the whole circle bearing ranges, and we will denote, I am denoting these as with the notation alpha. Now, when the angle is 0 to 90 degrees, that is, if our survey line is in between these two, the angle measured in whole circle bearing system is from north towards our survey line in clockwise direction. If we denote this one as alpha, in reduced bearing, how we are going to measure? Again, we are measuring from north in eastward direction only. So that is theta. So now in first quadrant, if whole circle bearing lies in 0 to 90 degrees, alpha is equal to theta. But what we have to do? We have to give directions: north, theta, east. Next, if our survey line is in second quadrant, 0 to, I'll call this one as O, B. Whole circle bearing value ranges from 90 to 180 degrees. Okay. Now, how we are going to measure the reduced bearing? South towards east. If I say this one as, I'll rub this to avoid confusion. Whole circle bearing is measured in this direction. So, if I call this one as alpha, and in reduced bearing system, we are going to measure the angle from south towards east in anti-clockwise direction. Now the reduced bearing is 180 minus alpha. This total angle is 180, and we need this one only. So now our reduced bearing becomes 180 degrees minus alpha. So that is equal to theta. Now what are the directions? We are measuring from south towards east. If our survey line is in third quadrant, again we are measuring our whole circle bearing from north towards our survey line in clockwise direction. We will denote this one as alpha, and we will measure reduced bearing from south towards our survey line in clockwise direction towards west, that is westwards. So now if alpha is our whole circle bearing, theta is our reduced bearing. Now theta is equal to alpha minus 180 degrees. You can see from the diagram. So this is 180 degrees, and we need this angle, that is theta. So if we subtract 180 from this alpha, we will get theta value. What are the directions again? South towards west, that is south theta west. And if our survey line is in fourth quadrant, again we are measuring our whole circle bearing in this direction, and the range is between 270 to 360 degrees, that is whole circle bearing range. So I will call this one as alpha. Now how you are going to measure in reduced bearing? So from north towards west. So in order to convert this whole circle bearing system, when our survey line is in fourth quadrant, so theta is calculated 360 degrees. So this total value is 360 degrees minus alpha. Got it? 360 minus alpha will give theta value. And what are the directions again? We are measuring from north towards west. North theta west. So in this way we are going to convert whole circle bearing to reduced bearing. In order to get more clarity, we will see some problems. So first one, convert whole circle bearing of 20 degrees to reduced bearing. "20 degrees means in which quadrant the survey line is in? First quadrant. So if the survey line is in first quadrant, we are going to measure from north towards our survey line, and this theta value given as, this alpha value given as 20 degrees. We are measuring in clockwise direction. Now we need to convert this whole circle bearing into reduced bearing. So how we are going to convert? So we need the directions. As I explained, the procedure same will be represented in this table. So if the angle is in first quadrant, that is alpha, whole circle bearing ranges from 0 to 90 degrees, and we are going to convert whole circle bearing to reduced bearing, then the angle theta becomes alpha only. Now This is alpha and theta equal to 20 degrees. Now, what is the solution? So, in which direction we are measuring? From north towards east, and theta value remains same. So, 20 degrees. And second one, if we convert whole circle bearing of 150 degrees to reduced bearing. So, 150 means our survey line lies in second quadrant. North towards, now alpha equal to 150 degrees. We need to remember, when alpha is in, or whole circle bearing is in second quadrant, theta becomes theta equal to 180 degrees minus alpha, that is 180 degrees minus 150 degrees, that is equal to 30 degrees. So, in which direction we are measuring? Reduced bearing is measured from south towards east. South east, angle is 30 degrees. And next one, convert whole circle bearing of 220 degrees to reduced bearing. 220 means, in which quadrant our survey line is? Our survey line is in third quadrant. Angle is 220. Which angle? This is whole circle bearing, that is alpha. Alpha equal to 220 degrees. Now, what is theta? Theta equal to alpha minus 180 degrees. So, that is this value from south towards west. So, this is equal to alpha is 220 degrees minus 180 degrees, that is 40 degrees. In which direction we are measuring? South towards west. South 40 degrees west. Next one. So, convert whole circle bearing of 320 degrees to reduced bearing. Now, our survey line is in fourth quadrant because it is having a value 320 degrees. When the value is in between 270 to 360, then the quadrant is fourth. Whole circle bearing alpha equal to, alpha is given as 320 degrees. Now, when alpha is in between 270 to 360, from the table you can see theta equal to 360 degrees minus alpha, that is 360 degrees minus 320 degrees, that is equal to 40 degrees. That in reduced bearing we are going to measure from north towards west, that is, this is theta. Now, we can write north 40 degrees west. Hope you understand the conversion from whole circle bearing to reduced bearing. Now, we will see the other, that is reduced bearing to whole circle bearing. So, you can observe the table. So, when the quadrant, that is first quadrant, reduced bearing is represented as north theta east, and if it is in second, south theta east, and if it is in third quadrant, south theta west, fourth quadrant north theta west. So, if our reduced bearing is or if our survey line is in first quadrant, reduced bearing is north theta east. Now, as the conversion from whole circle bearing to reduced bearing, the angle remains same. So, this theta, and how you are going to convert this one, or how you are going to measure whole circle bearing for this line. So, we are going to measure from north towards our survey line in clockwise direction, and we will denote it as alpha. Okay. So, now theta equal to alpha, and the value of the whole circle bearing, or this procedure is similar for when our survey line is in first quadrant. When our survey line is in first quadrant, theta equal to alpha, that is reduced bearing value is equal to whole circle bearing value. And we will see the second one. If the survey line is in second quadrant, then we will represent it as, you can observe in the table, we can represent this one as south theta east, and this is the theta. Now, for this, if I want to measure whole circle bearing, I will start from north towards our survey line in clockwise direction. So, this is alpha. You can see how you are going to measure theta. We know that this is 180. 180 minus theta will give the alpha value. Okay, same thing I have written here in table, alpha equal to 180 minus theta. Similarly, if our survey line is in south theta west, or in third quadrant, we will represent, okay, if our survey line is in third quadrant, so we will represent the reduced bearing south theta west. Theta is this angle, south theta, and this is west direction, and this is east direction. So, south theta west. And in whole circle bearing, how you are going to measure this whole circle bearing of this survey line? North towards our survey line in clockwise direction only. Will denote it as alpha. How you are going to calculate alpha? So, we know this one is 180. 180 plus theta will give the alpha. Alpha equal to 180 degrees plus theta. So, same thing we have given here. And in next case, if our survey line is in fourth quadrant, the reduced bearing is north theta west. North theta west. So, if our survey line lies in fourth quadrant, we will measure reduced bearing from north towards west in anti-clockwise direction. And we will represent this one as north theta west. So, in whole circle bearing system, how we are going to measure? From north towards survey line in clockwise direction. So, this is alpha and theta. Now, alpha equal to, we know theta value, and we know that this angle is 360. alpha equal to total this angle 360 degrees minus this angle, that is theta. Same thing we have given in table. When you want to convert from reduced bearing to whole circle bearing, you need to refer this table. We'll see few problems. We'll see few exercises on this. First one, convert reduced bearing of 20 degrees to whole circle bearing. So 20 degrees in which quadrant? So 20 degrees lies in first quadrant. And we are converting from reduced bearing to whole circle bearing. So our survey line is in first quadrant. Angle given is 20 degrees. So that is, you can take this one as north 20 degrees east. Now we need to convert this into whole circle bearing. So what is the whole circle bearing of this line? North towards this line in clockwise direction is again 20 degrees. So that is alpha theta equal to 20 degrees, alpha equal to theta, that is equal to 20 degrees. Now whole circle bearing of north 20 degrees east is 20 degrees in whole circle bearing. We'll see few exercises on this reduced bearing to whole circle bearing conversions. First one, convert north 20 degrees east to whole circle bearing. So north 20 degrees east is reduced bearing, and if it is denoted between north to east, survey line is in first quadrant. And this theta is equal to 20 degrees. When our survey line is in first quadrant, that is north theta east, alpha equal to theta, that is whole circle bearing system, whole circle bearing is equal to reduced bearing value, that is equal to alpha, and the value ranges is 0 to 90. For our problem it is 20 degrees. And second one, convert south 20 degrees east to whole circle bearing. How you are going to convert? Now south towards the angle is, the reduced bearing is south towards east, that is our survey line is in second quadrant. South 20 degrees east. Degrees is theta value. Now you are going to convert this reduced bearing to whole circle bearing. Just see this, alpha equal to 180 degrees minus theta, that is alpha equal to 180 degrees minus 20 degrees, that is 160 degrees. This value is 160 degrees. And we'll see another problem. Convert south 10 degrees west to whole circle bearing. So south 10 degrees west is in third quadrant. Okay. How you are going to calculate whole circle bearing? Alpha equal to 180 degrees plus theta. Theta value is 10 degrees. So 180 degrees plus 10 degrees, that is 190 degrees. How you are going to represent the line here? I'll show. This is 10 degrees towards west and OC. Now our whole circle bearing is this one, that is 180 plus this 10 degrees. Okay. Then fourth one, convert north 20 degrees west to whole circle bearing. North 20 degrees west is fourth quadrant. Then alpha is calculated using this formula. Alpha is equal to 360 degrees minus theta. What is alpha? Alpha is whole circle bearing. 360 degrees minus 20 degrees. 340 degrees. I'll represent in this figure. North towards west. So this line is in fourth quadrant, OD, and this is 20 degrees. So north towards west 20 degrees. And how we are going to measure whole circle bearing? From north in clockwise direction. This is alpha. Now we got 340 degrees. I hope you got a clear idea how to convert reduced bearing to whole circle bearing and whole circle bearing to reduced bearing system. These are the references for this topic. You can refer these textbooks. Thank you.